Hello everyone. Today we're going to do a lesson on chords. So this will be lesson 10.6. Now this lesson can be a little tricky, but if you just follow along it should be no problem. I'm going to give you the formulas, and then I'm going to give you an example of each type of problem you are going to see on your assignment. So let's begin with looking at what happens when you have two chords that intersect each other inside of a circle. So here I have chord AD and chord BE, and they intersect. Well, something kind of cool happens. If I take the length of AC and multiply it by the length of DC, it will always equal to the intersecting chord multiplied, BC times EC. Now if you notice right here, I wrote it out, AC times DC, AC times DC is equal to BC times EC. Now another way you can think of it, if you don't want to think of all the letters here, just take this segment times this segment equals to segment times segment. Now when you have this scenario, you can find missing variables. So if you would, write this down, and when I get to example number 1, then I can show you how this works. Now the second type that you're going to see is when you have two chords that are perpendicular to each other. Notice we have a chord here and a chord here, and it's perpendicular. Now what happens when they are perpendicular? Well, one chord will be bisected. It must be bisected. Okay, so yes, you can have bisected in other scenarios, but perpendicular, but they are going to be bisected. So in other words, this chord segment will be congruent to this segment. Now it's pretty obvious that the other chord is not bisected, okay, because you got a short length here and a longer length here. But that second chord will always be a diameter. Yes, so if one chord is bisecting the other chord, the second chord will always be a diameter. Now something is going to happen with this situation. These two chords are congruent, but look at the arcs. This arc will be congruent to that arc. Alright, example, if this is 30 degrees, that would be 30 degrees. And likewise, this arc here will be congruent to this arc. So if this was 150, this of course would be 150. And if you notice, it does make 180, because here's our diameter. 30 plus 150 equals to half our circle, 180. Alright, so this is going to come real helpful in a few minutes when I show you the examples of this type of problem. Now another type we're going to look at is what happens when you have two chords congruent to each other. Well, if you have a chord that's congruent to another chord, notice I put the tick for each one of these chords, they will always be equal distance to the center. So if I measure the shortest distance from a line to a point, it will of course be perpendicular. These distances will be congruent. So notice I have 2 and 2. So in other words, if this line segment was 8, that one would be 8. And if this whole line here was, say, 12, then this whole line would be 12. But there is also something else going on. If the chords are congruent, then their corresponding arcs will be congruent. So let's say this is 65 degrees. Well, then this one would be 65 degrees. And that is your 3 different formulas that we're going to look at for your assignment on 10.6. Now I'm going to give you 6 different examples, and which they're going to correspond with the 6 problems that you're going to be given on your assignment through forms. All right, here we go. Let's begin. Example number 1. Now, example 1 is using our chords formula, segment times segment equals segment times segment, and we want to solve for x. Well, if I take this segment and multiply it by this segment, I get 8x. 8 times x, 8x. Then I'm going to take 4, multiply it by 6. 4 times 6, segment times segment. 8x is equal to 24. Divide, x equals 3. Now you can plug the number in and you'll notice how that this will be equal. 3 times 8 is 24, 6 times 4, 24. And that's all you have to do. Let's do one more example number 1. This is also example 1. Pause your video and solve for x real quick. Okay, let's see if you got the correct answer. Segment times segment, so that's 12 times x equals segment times segment, 8 times 6. 12x is equal to 48. 48 divided by 12 gives you x equals to 4. And there you have it. All right, let's look at example number 2. Example number 2 kind of looks like the third formula or third different type of chord example I gave you, in which we have chords that are congruent to each other. So notice my ticks here and here being equidistant. Now we want to solve for x. Now what did our formula say about this? Oh, our arcs will also be congruent if our chords are congruent. So 20x is equal to 25x minus 15. Let's solve. 25x minus 15 equals to 20x. I always like my larger variable on the left. Let's bring the 20x over, but notice what happens. You have nothing left over on the right side, so don't forget to put your 0 here. Bring the 15 over, add 15. 5x equals 15, so x equals to 3. And that's all you have to do in order to solve number 2. All right, let's look at our third example. Example number 3, we need to find the measure of arc MN. Well, here is arc MN. Now look what we have. This is coming from our second formula that I went over with you. Notice how when you have a chord perpendicular to another chord, one chord is going to be bisected while the other one is going to be the diameter. So we know that these two are congruent, and there's your diameter. But what else is going on? We notice that our two corresponding arcs with the chords are also congruent. So if this is 50 degrees, then this of course would be 50 degrees. Now the question is, what is the measure of arc MN? Well, let's just use the little shortcut I showed just a minute ago. Here we have a diameter, which is half of a circle, which is 180 degrees. So since this is 180 and this is 50, to find arc MN, you just simply take 180 minus 50, and that will give you 130 degrees. And that's how easy example number 3 will be. Now let's look at number 4. All right, now number 4 requires a little bit extra work because number 4 is asking us what is the radius. So we want to know what is the distance from the center to the edge. Now every year when I teach this lesson, I have a lot of students that will mess this one up. So you're going to have to be really, really careful. So this is what I'm looking for. What is that radius? All right, so let's see what they have given us. First of all, we have two chords are perpendicular. So therefore, these two, or this chord is bisected. So C to center and D to center are congruent. And AB is the diameter. All right. Now, they do give us CD as 20. So from C to D is 20. And since this is bisected, we can divide this by 2, and this will give you 10 and 10. Now, if you look, this is very similar to our first formula. So we're taking our second formula and first one, and we're combining it. So segment times segment equals segment times segment. So therefore, from this point to B, we can label that as X. So I have segment times segment equals segment times segment. 5x is equal to 100. If you take the 100 divided by 5, you get x equals 20. That is not your answer. Okay, I'm afraid that some of you are going to stop right here and then you're going to find that number and place it as your answer. No, that is not your answer. We want the radius. So if this is 20 from here to here, and this is 5 from here to here, from A to B is 25. So that is the diameter. Now, of course, I don't want the diameter. I'm looking for the radius. So remember, to find the diameter, you divide it by 2. So radius is equal to diameter divided by 2. So 25 divided by 2 is 12.5. And there's your radius. So please be careful, number 4. All right, let's go on to example number 5. Example number 5 is going to be a problem about students going to a prom, and they're going to get their picture made under this floral archway. And the question is going to ask you, what is the diameter of the floral archway? In other words, if you were to complete a circle around this archway, what is the complete diameter of that circle? So from L all the way down to this point here. So that is what we're looking for. So even though they didn't give you this part, we can add it in. All right, so it's basically almost like number 4, except it just didn't have you, or did not have a complete circle. All right, Km is 8, so here's Km. Since this is perpendicular, this is a bisector, this is going through the center, so Kn and Mn are congruent. If this is 8, divided by 2, you get 4 and 4. Ln, here's Ln, that gives you 2. And then from N to our invisible point at the other end of the circle, we'll call X. So segment times segment equals segment times segment. 2x equals to 16, so x equals to 8. 8 is from here to here. What's the diameter? Diameter is from L all the way down. So you're going to have to add the 2 plus the 8, which gives you 10. So please be careful with this one. It's not asking for the radius. This one's asking for the diameter. All right, now comes our last example. It's actually pretty simple if you remember the Pythagorean theorem. So here we go. On problem number 6, they're asking you, what is the length of JK? All right, from J to K. No, we're not joking here. All right, so from J to K, we know automatically that these two are congruent because this is perpendicular and it's going through the center. So since it's perpendicular going to the center, these two chords are congruent. Now, if you look very carefully, here is our right triangle. All right, think to yourself, what did we do to help solve missing sides on the right triangle? Yes, the Pythagorean theorem. So we have A, B, C. Remember, the two legs are always connected to the box, and across from our right angle box is the hypotenuse. So we're going to label that X. We want to solve for X. So I have A squared plus B squared equals to C squared. 25 plus X squared is equal to 169. Take away 25. X squared is 144. And remember to solve for X. Take the square root. X equals to 12. So it is 12 from this point to K, but we don't want that. We want JK here to here. So if this is 12, that's 12. So 12 plus 12 is 24. All right, review this video as much as you need and use it to help you set up and solve the problems that you'll be assigned. All right, y'all have a good day.